In Chapter 4, we're going to talk more about the particles of matter and talk about models of atoms. Your book has some chemical history in it, and I think it's good to talk about it. I'm not going to test you on chemical history because this isn't a history class, but it's helpful to know where these things came from. So 1803, long time ago, but not ancient history, a guy named John Dalton proposed that all matter is made up of tiny particles. These particles are molecules or atoms. And the difference between those is that molecules can be taken apart into atoms by chemical processes, but atoms cannot be broken down by chemical or physical processes. The only way you can take apart an atom is through a nuclear process. And he came up with an atomic theory about atoms, and these were the principles of his theory. Remember, a theory explains behavior. A law just says what happens, and a theory explains why it happens. So his theory included this: an element is composed of tiny, indivisible, indestructible particles called atoms. Okay, so at the time, that was understood to be true. Now we know that you actually can destroy atoms, but only under special circumstances. So this first one has been qualified. The second one, all atoms of an element are identical and have the same properties. And at the time, because they did not know about the little particles inside of atoms, this was understood to be true. Now we know that it's not quite true. You can have, and we'll learn about them, they're called isotopes. You can have atoms of the same element. They're a little bit different. And so we have to qualify that a little bit as well. Atoms of different elements combine to form compounds. That is very true. Compounds contain atoms in small whole number ratios. That is also true. And atoms can combine in more than one ratio to form different compounds. An example is carbon dioxide and carbon monoxide. One is CO2 and one is CO. And so the ratio is 1 to 1 or 1 to 2. Same two elements, but two very different compounds. Carbon dioxide is not harmful. Carbon monoxide is harmful. If you're breathing significant amounts of carbon monoxide, you will die. It's bad. So the first two parts were later proven incorrect, and we'll look at that, but those last three are still accepted today. This theory was a very important step in the further development of atomic theory because, as your book mentions, there were a couple of Greek philosophers way back, I don't remember how far back, they had an idea that matter had a smallest particle that you couldn't cut in half. And Aristotle thought that matter was infinitely divisible. You could just, if you took a piece of, say, gold, you could cut it in half and cut it in half and cut it in half. And if you had a small enough knife, you could conceivably cut it in half forever and you would never get to a smallest particle. And people went with Aristotle even though he was incorrect. And so these ideas that a couple of guys had around that time went unused for centuries until Dalton came out with this atomic theory. This was a huge step forward. About 50 years later, this is another section. Let's stop.